Right, now let's continue with our lesson on motion, and now I am going to introduce to you some other quantities that we need to describe motion. Now, another quantity that we need to know that actually becomes very important when we're talking motion is time. Okay? And we normally talk about it as change in time, and I'm going to explain why. Now, time, why does it become important for us to talk about time? It becomes important for us to talk about time because when we're looking at how an object is changing position, we can also look at how long does it take that object to change its position. For example, in the initial graph that I had, we can actually measure or look at how long it took the object to change its position from position A to position B, or from position A to position F or D, for example. At any point, we can be able to do so. Okay? Now, time becomes important because when we know how fast something is happening, then we can tell a whole lot of other things, as I'm going to explain further. So time becomes important because it tells us how long it takes a particular event to occur. Okay? It takes an event to occur. And what is the event here? The event is the motion, is the movement. So in our case, we're talking the movement or motion of that object. Okay? So this becomes the event that we are observing, the event that we want to know or quantify. So time becomes very important. What other quantity can we talk about here? Now, once we have spoken about time, okay, I want us to go back to what we have spoken about earlier on, the question of displacement and distance. Let's start with distance. If we know how long it took, so we know the time, delta t, how long. Remember, this is not the time you watch, what it tells you. I can tell you what the time is now, but that is not the time I'm talking about. I'm talking about the period. I'm talking about the time it took something to happen. So that's why we're using delta t here to tell us that it is actually the time it took for something to happen. If we know this, and we also know how far this object has moved in that time, so we know the distance. And if that distance is along the horizontal plane, we will call it delta x. I mean, inconsistent as with your Cartesian plane, we know the vertical is the y-axis, the horizontal is the x-axis. Hence, we're using delta x if it is in the horizontal plane. Now, if we know this thing, we can actually begin to talk about the rate. Now, what is rate? Rate is anything per time. Okay? Anything per time. Right. Now, here, the rate of change of distance would be delta x over delta t. Okay? And that rate of change of distance is called speed. Okay? And speed, v. All right? The symbol for it. Now, here is another quantity. So from, if you like, from distance and from time, we're getting a new quantity. We're getting speed. Okay? Which is v. Right. Now let's look at what happens when we talk displacement. With displacement, we should be able to note, okay, displacement, we're talking about the straight line distance or change in position. Okay, so what happens on the other side when we talk displacement, not distance? The same thing may happen. Displacement can be along a particular direction. Can be along delta x, but being a displacement this time. And then when we look at the rate, so we're talking about, we're bringing in the time factor, delta t. If we have displacement over time, okay, delta x in a particular direction divided by delta t, if we have that, it gives us a special, one of the special quantities called velocity. And this, let me not go over there so that you can see what I'm writing. This is again v, but you must know that this has got a direction, so we put a small arrow there. But that small arrow is not to say that you can always show it there. You just have to understand putting the v is good enough for you to use to represent velocity or even speed. Thank you. See you in the next section.